Okay, so in this lesson, we're going to learn how to divide a polynomial by a monomial. Now, the skills that you're going to learn in this lesson is going to be important in the next lesson because in the next lesson, we're going to learn how to divide a polynomial by a polynomial with more than one term. So notice that the denominator here is a polynomial with two terms. So in this lesson, we're going to look at polynomials where the denominator is just one term. So for example, let's look at this problem. So the directions will usually say divide. Now, as we go through this, the way you write your answer is going to be important. So it'll say divide. So let's look at number one. So number one, we have 24x to the sixth power divided by 4x to the fourth. So notice that these are polynomials. Remember, a polynomial is a monomial or more than one monomial. So notice that you have a monomial here and a monomial here. Even though it's just one term, it's still considered a polynomial. Remember, a polynomial is one or more terms, one or more monomials. And so the way you're going to do this, the way you did this in a previous course is you said, well, 24 divided by 4 is going to give me 6. Now, for this part here, I'm going to go ahead and write this as you would think about it. So notice that this part you're saying x to the 6th divided by x to the 4th. Now what I want you to notice here is that in a previous course, you learned something about the quotient rule for exponents. Quotient rule for exponents. And so and so basically, remember the quotient rule for exponents said something to this effect. If you have x to the m power divided by x to the n power, then when you divide like bases, you subtract exponents. So this becomes x to the m minus n. And so that's just going to use here. So basically in your mind, you would say, well, I'm dividing like bases. So according to the quotient rule for exponents, I can write this as 6 times x to the 6 minus 4 power, and 6 minus 4 is 2. So this becomes 6 times x to the second power. So this right here, so your answer, you would say 24x to the sixth power divided by 4x to the fourth power equals 6x squared. And so that's your answer right here. That's your quotient. All right. So this is considered the quotient. All right. So number two, let's say we had this in number two. So let's say we want to divide another monomial by a monomial. So let's say we had 54 a to the seventh power b to the fourth divided by 9a cubed b. All right. So what in your mind, this is what you're thinking. You're saying, well, I have 54 divided by 9, right? And then I have a to the seventh divided by a cubed. And then I have b to the fourth divided by b, right? And so I know that 54 divided by 9 is 6. And I know that a to the seventh divided by a to the cubed based on the quotient rule for exponents. So when I divide like bases, I subtract exponents. So I know that a to the 7 divided by a to the third is a to the fourth, because 7 minus 3 is 4. And remember this right here, this denominator right here, that's b to the first power. So recall, there's no exponent there. That's understood to be a 1. So 4 minus 1 is 3. So this will be b to the third. And so that's your quotient. So so when you divide a monomial by this monomial, you get this. So that's your quotient. So we have 54, a to the seventh, b to the fourth, divided by 9a cubed, b is equal to, and that's going to equal 6a to the fourth, b to the third. All right. Now these skills, those skills that you're reviewing or that you may be learning for the first time, because these were actually in previous courses, but these skills here are going to be important, when we start dividing a polynomial by another polynomial with more than one term. All right, let's look at number three. So in number three, let's suppose we had this in number three. Let's suppose we had 20 x to the fourth plus 28 x cubed divided by 4x. So now notice I have two terms divided by a monomial. And so we're going to do this the same way we did before. Um, what I want you to remember is this, though. This may help you understand why I'm going to rewrite it the way I'm writing it. Do y'all agree that if I have, I'm going to write this as note, do y'all agree that if I have 8 plus, let's say, 6 divided by 2, all right, if I have that, y'all agree that that's the same thing as saying 8 divided by 2 plus 6 divided by 2? And so 8 divided by 2 is 4, and then 6 divided by 2 is 3, and that's just 7. You could have also said 8 plus 6 is 14, and 14 divided by 2 is also 7. But the way you're going to do this, since those are not like terms, is you're going to write it like this. So whenever you have a polynomial divided by a monomial, you're going to write them as separate fractions, just like we did this. 8 divided by 2 plus 6 divided by 2. So you're going to say 20, so this is going to equal 20 x to the fourth divided by 4x plus 28 x cubed divided by 4x. All right, so this step here, writing it as two separate fractions, is what we did here. And so now I'm going to use the same idea we used in 1 and 2, and using the quotient rule for exponents. Okay, so 20 divided by 4 is 5. X to the fourth divided by x, I'm dividing like basis, so I subtract exponents. 4 minus 1 is 3, so this becomes x to the third power. 28 divided by 4 is 7, so I get plus 7. X to the third divided by x, remember divide like basis, you subtract exponents. That's that quotient rule for exponents. And so 3 minus 1 is 2. And so there's your answer. All right, so in the blank, you would say 20 x to the fourth plus 20 x cubed divided by 4x is going to equal 5x cubed plus 7x squared. All right, so that's your quotient. All right, so number 4, that's number 4. So number 4, let's suppose we had this number 4. Let's suppose we had 25x squared plus 15x divided by negative 5x. All right, so same idea. I have a polynomial divided by a monomial, one term here. So the easiest way to do that is just to rewrite this as two separate fractions. So you're going to have your first term divided by the denominator. So it's 25x squared divided by negative 5x, and then plus 15x divided by negative 5x. And then you reduce. So 25 divided by negative 5 is a negative 5. X squared divided by x, when you subtract exponents, when we divide like bases, you subtract exponents, so 2 minus 1 is 1. So this is just negative 5x. So this part here is negative 5x. Over here, you have a positive 15 divided by negative 5 is a negative 3. And now remember, x divided by x is kind of like saying, I want you to remember this, 7 divided by 7 is equal to 1, right? 6 divided by 6 is equal to 1, correct? So x divided by x is also equal to 1. Now, you may say, well, can I use the quotient rule for exponents like I did here? Sure you can. So let's suppose we had this. Let's suppose we had this right here. So remember, x divided by x, when you subtract exponents, 1 minus 1 is 0. Now, one of the properties you learned is the zero exponent property. So the zero exponent property says that if you have a non-zero base raised to the 0 power, then that's just equal to 1. And so x divided by x is 1, so you just get negative 3. All right, and that's how you want to write it. You want to write this as negative 3. Make sure you remember that. All right, so be careful when you rewrite your answer. All right, so that's number 4. Okay, so let's look at number 5. In number 5, let's suppose we had 14x to the 8th plus 28x to the 5th minus 21x cubed divided by, and then let's say 7x cubed. All right, so this time you have 3 terms, so you're going to write this just like you did before as 3 separate fractions. So each of those terms in the numerator will be divided by this monomial. And so you're going to get 14x to the 8th divided by 7x cubed plus 28x to the 5th divided by 7x cubed minus 21x cubed divided by 7x cubed. And then you simplify each of those fractions. So 14 divided by 7, that's a nice number, that's 2. X to the 8 divided by x cubed. When you divide like bases, you subtract exponents. So 8 minus 3 is 5. So that's x to the 5th. Plus 28 divided by 7 is 4. X to the 5th divided by x cubed is x to the 2nd. 5 minus 3 is 2. And then minus 21 divided by 7 is 3. Now again, just like we did with this one, remember x divided by x is 1. So if I had x cubed divided by x cubed, remember that's anything divided by itself is 1. You could have also used the quotient rule for exponents. So 3 minus 3 is 0. See, that's x to the 0. And we know that according to the zero exponent property from a previous course or rule, then that's going to be equal to 1. So negative 3 times this 1, this right here is 1. And so negative 3 times 1 is 1. All right, so leave it though, it's negative 3. And so that's your quotient. So this divided by this is equal to this. All right, let's look at number 6. All right, number 6, let's suppose we had this for number 6. All right, let's suppose we had this. So we have 16m to the 5th n to the 4th minus 12m to the 4th n cubed plus 8mn divided by 4mn. All right, so notice I have a polynomial divided by a monomial. So whenever you have a monomial, you're going to write it as 3, in this case 3, separate fractions, and you're going to reduce. So that's how you can divide. So to divide this polynomial by this monomial, you're going to write it as this first term divided by the denominator, just like this, minus, and then the second term divided by the denominator, okay, and then the last term divided by the denominator. All right, and then you're going to simplify each of those. All right, so 16 divided by 4 is 4. Now you see the m's right here. You have factors of m in the numerator. You have one factor of m in the denominator. Now remember this exponent right here, and both m and n are both 1s. So 5 minus 1 is 4, so you get m to the 4th. 4 minus 1 is 3, so you get n to the 3rd. So this is this. Minus 12 divided by 4 is 3, so minus 3. Again, m to the 4th divided by m. 4 minus 1 is 3, so that's m to the 3rd. N to the 3rd power divided by n. 3 minus 1 is 2. Plus, and then the next one. Reduce this one now. A divided by 4 is 2. Now be careful. See, m to the m, m divided by m is 1, n divided by n is 1, so that's all you write, 2. So this right here is just equal to 2. So I want you to note 8mn divided by 4mn is the same thing as saying a divided by 4 is 2, m divided by m, subtract the exponents, that's 0, n, and then subtract the exponents here, 1 minus 1 is 0. Remember, m to the 0, n to the 0 is 1, so that's 2 times 1 times 1, which is 2, and that's what you have here. Okay, so that's your answer. So when you divide this polynomial by this monomial, you get this. That's your answer. Okay, 7. So number 7, let's suppose we had 8a to the 4th minus 12a cubed plus 4a divided by negative 4a. All right, so again, I have a polynomial divided by a monomial. So whenever you have a monomial, you want to rewrite them as separate fractions. That's the way you can divide. So you're going to say 8a to the 4th divided by negative 4a minus 12a cubed divided by negative 4a. You see that? So all of these are being divided by this denominator, since that's a monomial. Plus 4a divided by negative 4a. and then you just reduce, you simplify each of those fractions. So 8 divided by negative 4 is a negative 2. A to the 4th divided by a. All right, so remember, you divide like bases, you subtract exponents. 4 minus 1 is 3, so you get a to the 3rd. Now be careful here. You got to remember your sign properties. A negative divided by negative is a positive, because a negative 12 divided by negative 4 is a positive 3, right? Okay. And then a to the 3rd divided by a, 3 minus 1 is 2, so it becomes a squared. And then a positive 4 divided by negative 4 is a negative 1, right? And then a divided by a is 1. So I want you to note this right here. Let's think about this rational expression. So we have 4a divided by negative 4a. Okay, y'all agree that 4 divided by negative 4 is a negative 1? And then a divided by a is just 1, right? And negative 1 times 1 is a negative 1. And that's what this is. Okay, so there's your answer there. And then finally, let's look at number 8. So number 8, let's suppose we had this for number 8. We have 12x to the 4th minus 8x cubed plus 7x squared divided by 4x squared. All right, so again, I have a polynomial divided by a monomial. Whenever you're dividing by a monomial, you're going to write them as separate fractions, just like we did in all the previous problems. So we have 12x to the 4th divided by 4x squared minus 8x cubed divided by 4x squared plus 7x squared divided by 4x squared. All right, and so you're gonna simplify or reduce each of those fractions. So 12 divided by 4, I can reduce that. That's 3. X to the 4 divided by x squared. I'm dividing like bases, so I know that one of my properties says that when I divide like bases, I subtract exponents. 4 minus 2 is 2. Okay, negative 8 divided by 4 is a negative 2. I'm dividing like bases. I subtract exponents. 3 minus 2 is 1. And then over here, see x squared divided by x squared is 1, right? So let's talk about this. So I have 7x squared divided by 4x squared. Now I want you to notice I can't, you see how I was able to reduce 12 divided by 4 is 3, and then negative 8 divided by 4 is a negative 2. See here, 4, let me say this, 7 is not divisible by 4, and they have no common factors other than 1. And so I can't reduce this 7/4. So I want you to notice that it's going to be 7/4 times, and then x squared divided by x squared is 1. So that's just 7/4, right? So that's what goes here, plus 7/4. And there's your answer. Okay? Now, so what we did here was we talked about dividing a polynomial by a monomial. Now, remember when you're dividing and your denominator is a monomial, especially when you have the numerator being more than 2 or more terms, you're going to write them as separate fractions, and then you're going to reduce. Those skills, all those skills you learned here, these properties, these rules, the skills you learned in those 8 problems will help you to a certain extent when we get to a polynomial divided by another polynomial where the denominator is not a monomial. Okay? All right, so that is the end for this part of our lesson on dividing a polynomial by a monomial.